In this video, section 6.5, rational functions. So, the idea behind a rational function is we take two existing functions or expressions, say f of x is equal to 7x minus 3 and g of x, which is equal to 2x minus 5, and we look at the ratio between them. We make a new function. We'll call it h of x, and it's equal to the ratio of f of x and g of x. So h of x would be 7x minus 3 divided by 2x minus 5. And then we can do some solving. So let's suppose that we want to know when h of x is going to be equal to 8. Okay, currently we've got two instances of x, one here, one here. What do we want? We just want 1x, and then we can get x is equal to whatever. So let's get this x out of the denominator where we can't work with it, and to do that we're just going to multiply both sides of this equation by the denominator. We'll fill in the rest about it. These two will cancel. The left hand side will be 7x minus 3, and for the right hand side we're going to have to take that 8 and distribute it. So we'll have 16x minus 40. Now we're going to solve this just like we did previously. Say, subtract 16x from both sides. We'll fill in the rest of the equation about that. Minus 9x minus 3. The left hand side will be minus 40. We'll add 3 to both sides. It is, after all, inverse-reverse time. So that's a negative 37. And divide both sides by a negative 9. And we have a negative divided by a negative, so the result will be a positive 37/9. Let's look at another equation. I want this one to be a little bit different. I want 4x plus 5 divided by 3x to be equal to 2x minus 7. We need to get rid of this 3x. Got to get it out of the denominator. So we're going to multiply both sides of this equation by 3x. We'll fill in the rest about it. Okay, so these will cancel. The left hand side will be 4x plus 5, and as for the right hand side, we're going to have to distribute. So 2 times 3 is 6, x times x is x squared, and we've got a minus 21x. And this is what makes this problem different. We're going to have to use the quadratic formula to solve. So that means we need to get this in standard form. So we'll subtract 4x from both sides, subtract 5 from both sides. We'll be left with 0 is equal to 6x squared minus 25x minus 5. So in terms of the quadratic formula, a is 6, b is a negative 25, and c is a negative 5. So going to be some large values, but that's okay. We can handle it. So x will be equal to a negative 25, plus or minus, let's see here, the square root of negative 25 squared minus 4 times 6 times a negative 5. And then our denominator will be 2 times 6. Let's start to simplify. Negative negative 25 makes this a positive 25. Plus or minus the square root of, see here, 25 squared is 625, and this simplifies to be 96. Note the two negatives, 1, 2, making it positive. And this will all be divided by 12. So after we simplify, we'll get 25 plus or minus, let's see here, 721, square root of that. And this entire thing will be divided by 12. I want to go back to the function h of x that we created and just think about some of its properties. And if you'll recall, we said this was f of x in the numerator, and we called the denominator g of x. Now, what if f of x is equal to 0? Well, that would mean that, let's see here, 7x minus 3 is equal to 0, 7x is equal to 3, x will be equal to 3/7. So h of 3/7 is, well, 0 in the numerator. 2 times 3/7 minus 5. And this is something that's not 0. So 0 divided by something that's not 0 is equal to 0. The answer is h is 0. The result of our function is 0. This is a root of this function, h. Okay, what if g of x is 0? So that would mean we want 2x minus 5 to be equal to 0, 2x is equal to 5, x will be equal to 5/2. So h of 5/2 will be 7 times 5/2 minus 3 divided by, well, 0. And once again, this is not 0. So we have something that's not 0 divided by 0. H of 5/2 does not exist because of that division by 0. We can't have that. So that would mean when the denominator here is equal to 0, h does not exist. When this numerator is equal to 0, h is 0 as well. Okay, that's it for section 6.5. Thanks.